Hello, and thank you for joining us for our webinar with ArcelorMittal. I'm Nick Holt, editor at AMS. This session will cover ArcelorMittal's multi-parts integration concept. Now, this has been designed to incorporate a number of parts into one laser welded blank. The MPI concept uses press hardenable steels and hot stamping laser welded blank technology to create the single part with the goal to simplify production for OEMs. To find out more about this, I'm joined today by two experts from ArcelorMittal. Jesse Pageli, who's Head of Product and Solution Development at ArcelorMittal Tailored Blanks and Product Development. Jesse's had a long career in the automotive industry, working with leading companies such as Renault, ArcelorMittal, Angus Stamp, and he has extensive experience within the sector, including the development and launch of new vehicles. Our second expert is Joel Villiers. He's a technical support leader for the automotive steel solution design at ArcelorMittal's global R&D department. And Joel has worked for ArcelorMittal R&D since 2001. And in 2014, he joined the company's steel solution design department as leader of the co-engineering projects to provide lightweight steel solutions to OEMs. So before we get our presenters started, I'd like to invite all of you to ask any questions via the Q&A box. It's in the lower right-hand side of your screen. So we'll be having a Q&A session with Jesse and Joel at the end after their presentation. And if you experience any technical difficulties, you can pass on some comments there to our team here, and we'll do our best to help you out with that. So without further ado, I shall now hand over to Jesse and Joel to begin the presentation. And I believe it's Jesse starting to begin with. Thanks very much.
Exactly, Nick. Thank you so much for the kind introduction. And at this point, I will hand over the presentation. And the idea today is to share with you a new concept that we developed inside ArcelorMittal Tailored Blanks, that we call it multi-part integration. The idea here is really try to simplify the life inside the body shop for OEMs as we are facing a transition period to electrification. And this is a short introduction that I'm going to do right now. And afterwards, I will hand over the presentation to Joel, who is going to present the results of the two first big panels or big parts that we developed this year in 2021. So the first step is to look a little bit behind and to understand which is the complexity we are talking about. ICE vehicles were the powertrains that in majority were produced inside the body shop. So I cannot say that the life was easier before, because body in white concept is not easy, but we are adding some complexity today, because we are moving to the electrification, as I mentioned before. So today in the body shop, we need to deal with different powertrains, BEVs, PHEVs, ICEs. I can even add fuel cells, for example, in some cases. And all this makes the life a little bit difficult inside the body shop. What I'm trying to say here is not only the design is different, but the weight of the vehicle is different, the position of the battery is different. So it means that as much as possible, if you can at least have a common and modular solution, the best it will be for the moment that we are living today. Moving on, yeah. So some key factors that I would like to highlight before explaining what and which are the axes that we defined it as key factors for ArcelorMittal Tailored Blanks in this project is starting with CO2 emissions. This is a point that we need to take into consideration today, and the life cycle assessment in general. But we cannot forget that we need to keep the crash behavior, one of the oldest benefits of laser welded blank, mixing energy absorption and the protection of the cockpit. Cost saving, I need to bring to the market a solution that can be cost competitive. And this is the way we think, and this is the way we believe it's the solution that we are bringing to the market. One point that is important also as well, by bringing laser welded blank to big panels, we are reducing the amount of spot welds inside the body shop and reduce the subassembly operations inside the body shop. So this is one of the benefits of the multi-part integration design. Mass saving is another one. Of course, we still have to reduce the weight of the vehicle as we are increasing, in fact, in other hand, by using big batteries and so on. So function integration, reduce the weight to improve the autonomy of the vehicle is also something to take into consideration. As I mentioned before, CO2 emissions. And I like a sentence that I used to use and to share with the people I discuss it with about CO2. The less material you use, the greener you will be. So by using less material, we are going to save CO2 emissions at the end. The next slide is linked to the axis and detailing a little bit the axis that we put in place and we are using as the basics for the multi-part integration concept. The first one is linked to the part integration itself. So I need to reduce the complexity. So I need to integrate as much as possible parts in just one part. And it's important to say also as well that we are taking advantage of the industrial facilities that we have today. If you look the hot stamping lines that we have in the market today, they are able to produce big panels like we are going to see afterwards with Joel for the two parts that we would like to share with you today. Commonality, modularity. I guess it's a key point also as well as we are dealing with different powertrains. As much as possible as I can use exactly the same part for several vehicles, the better it will be in the assembly operations inside the body shop. So it means I am trying to reduce the complexity inside the body shop by increasing the complexity of building big panels like we are going to see, but at least in the assembly shop, we are going to save complexity. Crash management, as I mentioned in the previous slide, is one of the benefits or oldest benefits of laser welded blanks, and this is what we are putting together also in this big panel. So we are keeping these benefits for these big parts in the multi-part integration concept. Fourth, CO2 emissions. So nesting optimization, meaning that I am saving material, I am reducing the amount of material I need to produce one part by nesting better. We are going to see some examples in the detailed presentation that Joel is going to do. Last but not least, cost assessment. We also proceed a complete evaluation of the cost benefits that we can bring with these parts. And in this case, I'm not just looking for the part itself or the price of the part itself, but also for the correlated benefits that we can bring by reducing the space inside the body shop, by reducing the spot welding operations inside the body shop, and by reducing the complexity. Less space, less complexity, I going to save money and I going to save time, as we are going to see in the next slide. In this one, it's a quite interesting schema because we are trying to compare the standard concept that we have today with several parts. So in this slide, you can see what is happening today. So we arrive with coils. We need to cut these coils somewhere. We need to hot stamp or to cold stamp these coils, laser trim for the hot stamping, logistics, subassembly operations inside the body shop, logistics again, and to arrive to the line at the end. So this is the situation that you are facing today inside the body shop. Imagine this by adding different concept, different designs, different parts by the different powertrains that we have. What we are proposing is the following. It's just now we are reducing. Again, I insist on the fact, I know that probably is repetitive, but reduce the complexity is one of the points. So we are going to deliver the part, the big part, directly to the hot stamping. We need logistics anyway. We need to transport this part. I need to put in a press hardening line. I need to stamp, I need to laser cut also as well. But you can see even in this schema that I am reducing the space that I need. And by the way, I am reducing the cycle time to produce each vehicle. I am giving to ourselves the responsibility to simplify the life inside the body shop by making these complex parts. As you can see here, the multi-part integration concept that we are going to explain today during this webinar, more in details afterwards with my colleague Joel. So let's see what exactly we put in place this year in the multi-part integration concept. We planned for 2021 three main parts to be evaluated, and two of them we are going to present to you today. One of them is the edge frame, the here edge frame, where I am integrating the here rails with cross members to have just one part. And we are going to see how we can be modular, and I can commonize the part for different powertrains. The second one that we are going to present today is the double door ring. The double door ring is a concept that can simplify also the life inside the body shop, because I am integrating even the front and the rear part of the side area of the part, not only for the outer, but also for the inner part. And this concept is quite interesting, because in fact it's really a big panel. And if you look for the door rings that we have in the market today, because we are producing door rings, ArcelorMittal tailored blanks, and we developed together with some customers the door rings, but I'm talking about the front door ring. And here I'm talking about the two parts, the front and the rear part of the door ring. So again, we are trying to integrate as much as possible the parts to simplify the life inside the body shop. I guess it's a key word for today: simplification. Simplification, because we are dealing with different powertrains. We are dealing with different requests from the customers and the markets, and we really don't know how many years we are going to deal with this. So we need to find a way to simplify it in a cost-effective way. The third part, unfortunately, we cannot present today, is linked to the underfloor environment of the vehicle. As I mentioned before, the differences between PHEVs, BEVs, ICEs, tunnel, no tunnel, concept, cross members, protect the battery, protect the occupant. So there is several things that we need to put together. And this is a specific study that we did not finish yet. We are going to present, and I would be more than glad to share with you beginning of 2022. And by saying this, I would also like to share, and I will come back for the conclusions after the detailed presentation of Joël, that MPI, or in short, it's multi-part integration, is not a one-shot project. It's not something that we are doing today and we are going to stop in 2021. It's something that we already brainstormed for 2022, 2023, and we have several other parts that we are evaluating to support this transition period to the electrification, trying again to simplify as much as possible the life inside the body shop in a competitive way in terms of cost, because I believe that in this matter, it still can bring some benefits, not only in performance, but also in terms of cost and CO2 emissions at the end, because as I told before, we are using less material by applying this kind of part. So I'm nesting the parts better and taking advantage of the material utilization of each coil that we are producing and you are going to use inside your body shop. So it's more to come. And I come back for the conclusions. And from now on, I leave the stage to Joël, who is going to go into details for the both parts that I presented, the H frame and the double dooring.
So thank you, Jesse. On my side also, I would like to say good morning, good afternoon, good evening to everyone. So I will give you some details on technical results we obtained for the two first solutions, so the rear edge frame and the double dooring. So first, the MPI approach has been applied to the rear underbody of an SUV vehicle. So ArcelorMittal generic SN Motion SUV vehicle has been used as the basis to design the solution and to validate the concept. So this solution is called the rear edge frame. The rear edge frame integrates 11 parts, including the two rear rails, the rear cross member, and several reinforcements into one laser welded blank. The solution makes maximum use of the hot stamping technology and ArcelorMittal's press hardening steels, UZ-bore and Ductibore. So combining 11 parts into one single laser welded blank allows OEM to reduce the weight of the final part by 10%, going from 14.4 kg to 13 kg. As there is only one final part, less assembly steps are required. So in the case of the rear edge frame solution, we could considerably reduce the body shop complexity as 136 spot welds could be saved on the sub-assembly. Integrating a large amount of parts into one single laser welded blank leads to more complex geometries. So hot stamping feasibility of the rear edge frame solution has been validated through numerical forming simulations. The analysis shows that forming is safe in regards to the forming limit diagram in each areas of the part. No cracks or wrinkles are detected. Thinning is also in an acceptable range. Using the MPI concept, one modular solution can be developed for multiple powertrains, including ICE, BEVs, HEVs or PHEVs. So as shown here, the solution is nearly similar for a PHEV on the left-hand side and a BEV on the right-hand side. The part shape, the material distribution are similar for every powertrain. Only the patches at the front are specific so that crash performances are maintained. The rear H-frame solution has been assessed against all relevant safety requirements for the global market, including the 2AHS rear impact and the full width rear impact tests. So looking here at the 2AHS rear impact, the crash simulations demonstrate that there is no contact with the battery pack or the fuel tank on the SN Motion SUV, PHEV, or BEV models. The use of the press-hardening steel grade UZ-bore and ductibore in one single laser-welded blank is a key to multi-part integration. UZ-bore, shown here in red color, offers the strength and anti-intrusion properties required to protect the vehicle's occupants and the power system. And ductibore, shown in orange color, provides ductility, enabling crash energy to be controlled and directed away from the passenger's compartment and fuel source. And working in combination, these grades enable to enhance safety while reducing the total mass. The MPI approach offers many sustainability benefits. So the material savings, thanks to advanced nesting and the overall mass reduction on the final part, allow to reduce the CO2 emissions during the vehicle's life. So less steel avoids emission from steel production. And in case of the rear H-frame, advanced nesting optimizes the amount of steel used from 74% for the baseline up to 86% for the laser-welded blank solution. And this represents a 4.3 kg material savings per vehicle during manufacturing. To evaluate more precisely the impact on CO2 emissions, a detailed life cycle assessment has been performed on the component level. Here, metal production, part manufacturing, and recycling were considered. So the vehicle use phase was not taken into account here. We also considered European context in terms of steel sourcing and energy mixed. And with this hypothesis, we estimate that the integrated rear H-frame solution allows to reduce the CO2 emissions by 22% compared to a conventional design. So the MPI concept allows to drastically reduce the forming and assembly operations. In the case of the rear H-frame solution, we estimate that the working space required to produce the module can be reduced by almost half. Only one forming step is needed, and 136 spot welds can be saved on the subassembly. And that gives OEMs the space they need to deal with different powertrains during this transition phase to electrical mobility. Cost, of course, is important, an important point. So the MPI approach allows to reduce the total cost of the component. The analysis has been performed by an external partner specialized in costing. So the methodology uses an ideal virtual plant which produces 150,000 vehicles per year during 5 years. And as we can see here in the chart, the laser welded blank rear edge frame allows to cut costs by 3% compared to a conventional design. The MPI approach applies for even bigger parts, such as the double dooring. So the double dooring integrates the structural parts of the body side from A to C pillar. And 2 double doorings have been designed, one for the inner layer and one for the outer layer. Combined together, they allow to reduce the number of parts from 13 to just 4. So reducing the number of subparts allows to drastically reduce the number of assembly operations. And here, the number of spot welds goes from 310 for the baseline to just 66 per vehicle for the double dooring solution. And this represents an 80% reduction. And here again, the MPI solution helps to significantly reduce the body shop footprint. Using the hot stamping technology and ArcelorMittal's press hardening steels, UZ-bore and Ductibore, we also managed to reduce the weight of each double dooring by 10%, reaching a total mass savings of nearly 10 kg per vehicle if combined together. So the double dooring solution is compatible with any kind of powertrain, so ICE, PHEVs or BEVs. Crash simulations and crash validations have been performed using ArcelorMittal SN Motion SUV BEV because such vehicle has the most stringent requirements. So all relevant safety requirements for the global market were validated. For all the load cases summarized here in this table, very good crash performances are reached with the double doorings, as I will show it in the coming slides. So first, the small overlap. So a very good rating is obtained in regards to the intrusions. As we can see, the body side structure made of hot stamped laser welded blank double dooring ensures an efficient occupant safety and battery protection, as we have no contact with the modules. In the case of the US NCAP 50 percentile pole test, the double dooring contributes also to the battery protection, as we have no contact with the modules, despite the very severe crash conditions. And the body side structure ensures also an efficient occupant safety with a very low intrusions, as we can see on the B pillar profiles. For the next crash load case, which is the new Rio NCAP AEMDB side impact, low intrusions in the B pillar area are obtained. And these good performances can be reached thanks to the double dooring that combines ductile area in the B pillar lower and rocker that is made of Ductibore 1000 for energy absorption, and an anti-intrusion area made of UZ-bore 1500 and UZ-bore 2000 for resistance. So similar observation can be made for the North American version of the side impact, so the 2AHS side MDB here on the left-hand side. And finally, for the rollover crash, we also checked this load case, and we can see that the body side structure allows to reach a high roof crash resistance. So as I already mentioned, as a double dooring is one of the biggest and more complex part of the body in white. And it was here also important to check the feasibility of the solution through hot stamping numerical simulation. And as we can see here for the double dooring outer, the analysis shows that the formability is safe in regards to the forming limit diagram. Forming simulations show also that thinning is in an acceptable range and no cracks or wrinkles are detected. So for the double dooring inner, similar conclusions. In this case also, the part is safe in regards to the forming limit diagram. As for the rear edge frame, nesting optimization of each sub-blanks allows to increase material utilization, going from 63 to 68%. Material gross weight can be reduced by 12.7 kg per vehicle for the dooring inner. And these material savings, in addition to the final part weight reduction, allows to reduce the CO2 emissions. Same conclusions for the dooring, double dooring outer. The important material savings of 1.3 kg per vehicle will have a positive impact on CO2 emissions. And for this application also, a dedicated life cycle assessment is ongoing to evaluate more precisely the impact on the CO2 emissions. So double dooring allows also to drastically reduce the forming and assembly operations. In the case of the double dooring outer, we estimate that the working space required to produce the module can be reduced by almost half. So only 2 forming steps are needed, and 79 spot welds can be saved on the subassembly. And this is similar for the double dooring inner. Regarding cost, so the analysis shows that a cost reduction of 8% with the double dooring outer can be achieved. The use of the double dooring inner leads to a cost increase of 10%, but the mass savings cost of 2.2 euro per kilo saved is still at an acceptable level. Anyway, when combined together, the double dooring outer and inner allow a weight reduction of nearly 10 kg per vehicle at neutral cost. So coming now to the conclusion, we have seen that the multi-part integration concept allows to integrate a large amount of parts into one single component, thanks to the laser welded blank technology. This brings many advantages to OEMs, such as the reduction of the body shop complexity and the body shop footprint. The integrated solution may lead to quite complex geometries that can be achieved thanks to the hot stamping technology and the use of UZ-bore and ductibore products. Feasibility of each solution has been validated through forming simulations. So using the multi-part integration concept, one modular solution can be developed for multiple powertrains. The laser welded blank technology combined with press hardening steel grades lead to optimize the solutions in terms of component weight as well as material utilization rate. In addition to this material and weight savings, MPI concept can also bring cost savings in comparison to a conventional design. Regarding crash, the solution meet all relevant safety requirements for the worldwide market. Crash behavior can be really optimized as the multi-part integration solution combines anti-intrusion and energy absorption properties in one single component. And finally, multi-part integration offers considerable sustainable gains. We have seen in the case of the rear edge frame that CO2 emissions can be reduced by 22% compared to a conventional design, thanks to the weight reduction and the increased material utilization rate. And now I leave the floor to Jesse for the final conclusion and some outlooks.
Thank you, Joël. Hi, everybody again. And I believe that the concept that we presented to you today, more than believe, I hope that it was interesting. Some points that I believe it's important to highlight and to keep in mind, and in general, is that we are trying to simplify the process inside the body shop, and adding the fact that the less material we use, the greener we will be. I insist in this fact because it's important to keep in mind also as well. And yeah, I would say that we are taking advantage of the press hardenable steel's feasibility benefits to produce these complex parts, and this is the way we are going to proceed next year for 2022 with new parts, more to come, as I mentioned before. So more interesting insights expected for 2022. So by saying that, I would like to thanks and to say that it's a common work done by IMTB, ArcelorMittal, Tailored Blanks, and R&D team, and the benefits are here. And for the next year, just one point that I was almost forgot is that we are going to have some prototypes, a proof of concept for next year also as well, that we will present for you in general. So thanks Joël for presenting all the details of the project. Thanks for the audience, and yeah, let's go for the Q&A.
Thanks, Jesse. If Joel wants to come back on screen, and we'll get started on the Q&A. Thanks both. That's a really interesting presentation and attracted a lot of attention. And it's something you pointed out right at the beginning there, just how complex the vehicle platforms and the architectures are with the multiple powertrain options, which are still with us. I mean, I think there's a big focus at the minute around pure battery electric vehicles, but actually the reality is most car makers are still producing a wide variety of those vehicles. As you say, in a body shop, that's quite complex, especially with the floors and the bulkheads. I mean, there's a lot of challenges there. So very interesting solution that you've presented there. We've got time for some questions. There's a couple of things I was going to just ask you about, but I think we'll just go to the questions first, and I might just bring those up in sort of part of the conclusion. I mean, looking at the hot stamping lines, so are these adapted for the size of parts that you're talking about here? Do they need to be adapted?
Yeah, it's a good point, Nick. I can take it to answer. In fact, it's a kind of a tricky point, but it's the size of the lines that we have today installed in the market in the different tier ones are really adapted to produce these kind of parts. I would say that we have today in production several door rings already in production. The front part, at least, this is the concept that we have today. We have these parts under production in I would say all around the world, mainly. But what brings to me to the fact that one of the points that we looked at was exactly this. So if they are producing door rings today, big panels like this, why not take advantage of these kind of lines to produce also other parts? And it was a discussion that we had together with different tier ones and also with OEMs regarding this feasibility. So what I can say to you, I can assure that the lines that we have in the market today, not all of the lines, but there is enough lines to produce these kind of parts that we presented today in this webinar, even the double door ring.
There's a question here. I mean, the multi-part concept and a lot of the tailor welded blanks and the kind of structures we're seeing are focused around hot stamping processes. The question here, can it be applied to a cold forming process?
I can start with this. I guess Joel probably he has some comments afterwards, but it's an extremely good point. It's an extremely good point. In fact, we started the multi-part integration concept by focusing the PHS material, because the parts that we were analyzing were much more in PHS. As you can see, a door ring or yeah, you can see B pillars, H pillars, hinge pillars, even hookers sometimes. Okay, it's whole format, but in any case, there is the majority of these kind of applications are for hot stamping. But indeed, this is an extremely good point, and I would say that we can take advantage of some of the grades that ArcelorMittal is developing today, like the third generation, increasing the feasibility of cold stamping material and so on, to produce this kind of concepts by using a cold forming process. I would like to add one point that, of course, I cannot disclose, but we are discussing with some customers about exactly this, specific solutions for cold stamping and trying to integrate the parts in the cold stamping. Not easy, it's true, because sometimes the geometry is quite complex, but possible, and it's in the pipeline also as well. Yeah, go ahead. Sorry, Nick.
No. I was going to point out, so hot stamping technology has developed a lot over recent years, and now is the volumes you can put through now. it's really become, not that it's not been mainstream, but it's really become a key enabler with the using high strength steels in the vehicle body architecture. So, but again, an interesting point there about cold forming and various different things. I'll just move on to one more thing. You mentioned geometry there. How do you manage the geometry tolerances in the body in white assembly?
Joel, can you take this?
Yeah. So of course, it's an important point, especially when we deal with such big parts. And here we take advantage of the hot stamping technology and the advantage in regards to the geometrical accuracy. So that's how we can deal this point. But anyway, we have a detailed analysis on that point with a partner, an engineering office, to look at this point.
Because one of the things that I know from visiting body shops in the past, that I mean, the whole premise with this was to simplify as well, but complex body in white architectures can be quite challenging to produce in a world, and they require a lot of fixtures, fittings, etc., just to get them out there. And if I mean, the push for automation has made obviously pretty much most manual operations in a body shop now redundant, mainly because a lot of the need for this kind of accuracy and geometry. So, I mean, adding in a new sort of concept like you're bringing in here, obviously, if it's kind of workable, then that's and simplifies that, then that's a good thing. A question here regarding the patches that you discussed within the structures, and kind of how they're incorporated, fixed, joined into the structures. I mean, is it sort of welded or spot or seam welded? How are you able to disclose that or discuss that?
Yeah, we can. Joel can complete afterwards. Just a point in our portfolio for the ArcelorMittal tailored blanks. We already have patches applications that we are delivering to customers, and this is exactly the idea that came to our mind at the beginning, saying, okay, we have tailor welded blanks, but why not use patches to localize the reinforcements and to do the main process that we have today. The main process that we have today is spot welded patches. Okay, this is the process that we use for patches inside. And yeah, don't know, Joel, if you can, if you have something.
Yeah, for the rear edge frame, we considered spot welded patches.
Okay. Something, and I was making a note of this as well. You were talking about the multi-part project is not kind of like just a fixed here and now process. It's actually looking forward and developing it. You mentioned the door rings. Seen a lot about those over the last few years, about the multi-material door rings and the H frames. You did allude to it. I'm not sure how much you can reveal, but I mean, what other parts will still be evaluated in the future that you're kind of, what areas, I suppose, with the thing are you looking at that you might be able to reveal?
This is a good question. This is the reason Joel is laughing, because in fact we did a brainstorming session with our teams, with the teams in R&D and ArcelorMittal tailored blanks, looking what is going on in the market and so on. I cannot disclose which are the specific parts that we are going to work on next year, because there is some reasons behind it. Yeah, I cannot disclose right now. But what it's just a tip. It's as we started the discussions talking about the floor environment of the car and so on, that we did not present it today because it's not finished yet. This is something that we are looking more in details for the future. Yeah. Which part, which kind of solution, I cannot disclose for the moment.
This solution for making the body structures light and strong, obviously, is need. Looking further forward still, there's a lot of talk around kind of autonomous vehicles where the vehicle architecture will change completely. So you'll lose that kind of front and rear end sort of crash area. And they are, the designers probably won't thank me for saying this, they're kind of essentially big empty boxes that the interiors will be reconfigured and repositioned. That's the kind of view that how autonomous will go, you know, vehicles will become. As a designer trying to create, obviously the door rings will be important, floors, etc., but you kind of lose certain structural areas. But this kind of, I mean, in my mind, I see this kind of solution working very well for that, because you can reinforce parts of those larger structures. And kind of second part of this, do you see a lot of startup EV guys are working with very automated modular assembly processes, and that's really got to be simple. I mean, they're simplifying or trying to simplify that as much as possible. Again, looking in your, as far as you can reveal, in your sort of forward planning and thoughts about are these kind of things that are featuring into that for this concept and developing it further along those lines?
Yeah, Nick, definitely. Again, a nice one to share, because in fact, when we talk about the multi-part integration concept, we can think about it to improve the crash behavior, to protect the battery. We can think about other points, but at the end, we can apply the multi-part integration concept to anything that you want. The modularity, I can maximize, for example, the modularity of this kind of vehicles as a priority instead of one on another point. So the 5 axes that I presented at the beginning of the presentation is exactly the axis that we are looking for in general for the whole thing. But I can maximize one and another depending to the application. There is the beauty of the multi-part integration concept is the flexibility of the project. So we are flexible depending on what is going to happen in the market in the future. As we don't know, as we don't have, we have some ideas, but in general, nobody knows at the end what is really going to happen. So multi-part integration concept is really flexible to adapt to the scenario that we are going to find in the future. I can push more for modularity, as you mentioned before, autonomous vehicles and so on, than other things. So it's flexible. It's flexible. It's a good word, I would say.
We always ask our experts to give us that crystal ball view into the future, which is what everybody wants.
We need to.
I'm sure you'd like somebody to be able to explain that to you as well. We're coming to the end of the session. We've got a few questions stacked up. Just to let the audience know that keep sending your questions in, because all the questions will be passed on to the ArcelorMittal team and they'll respond. They can respond more fully back to you after the event as well. So a question here, again, engineers are coming in with kind of application and integration kind of questions. In terms of how do you handle issues with kind of wrinkling or springback with using the patches and inserts? So that's kind of one question that's popped up here. That's something you can answer now, or is that something you want?
Joel can go for that, yeah. Joel.
Also wrinkles and I didn't get the second point.
Wrinkles and like springback.
Springback. Okay. So here the patches were applied to hot stamped laser welded blank. So in regards to wrinkles, of course, we performed the numerical simulation to check this. So the position of the size of the patch, the number of spot welds was important to deal with this and to optimize the shape of the patch. In terms of springback, so as the part is quenched in the dies, we get a very good final geometry, so no springback are expected.
And it just brings me to just an interesting point. The modelling capabilities that you now have for forming steels, in the sense of you can simulate something, and you can figure out where cracks might appear, spring back, what the relationship is, depending on the complexity of the part being formed. Has that facilitated this project a lot, in the sense of being able to move it forward quicker, in the sense, you know, that you have a greater visibility from those sort of kind of digital simulations, and more importantly, perhaps the accuracy of the information from them in validating the design and the process?
Yeah, of course. Before performing a crash simulation, the first point was really to check first if the concept is feasible in terms of forming. So before going into CAE with crash iterations, we performed a numerical forming simulation to optimize the geometry of the part, the position of the weld lines, the size, the position of the patch. And then there was some fine tuning during crash iterations. And perhaps another point is that, as mentioned, Jesse, we are performing physical prototypes, really to have a proof of concept.
I think we're probably out of time now. There's a few questions stacked up here. As I say, we'll pass these on to you, and you can reply in due course to the audience. So just to say thanks to Jesse and Joel for a really interesting presentation. We follow these things as they develop, and we see them being brought in, and you guys highlight the sort of challenges and solutions that are out there. So it's been really, really interesting. For anyone who's not able to, or any of your colleagues that haven't been able to join the webinar today, or if you'd like to follow up and watch it again, it will be available on the AMS website in the next day or so. You can go there and you can check on the, I think it's the Spotlight tab now, and all the webinars that we've done previously are on there as well. So just wanted to say thank you very much to Joel, Jesse, for your time, insights. And thank you for everyone for joining us today, and hope you will join us for our next webinar in due course. Thanks very much.
Thank you.